Thank you, Jose, and thank you for the organizer to give me a brief chance to introduce to you, for those that haven't heard about it, the PR Challenge. This session is about filling gaps, and you saw a number of studies through this workshop here where different methods are being applied to fill gaps, from going from individual proxy locations and then using relationships with spatial geophysical structures to expand in the reach of the information from these few points to say something about the large scale, to say something about the dynamics that might be involved, to explain the variations that we see in the proxy records. But by doing so, we also base our work on certain assumptions. And these assumptions sometimes are a little on weak feet, on weak footing, and one reason is we have relatively short instrumental records and a whole bunch of other things. We heard about uncertainties in proxies before. So what we try to do here with this PR challenge, the Paleoclimate Reconstruction Challenge, but the PR is just as much a PR as you understand it as first as a PR, is to actually test or seek a way to test how much certain assumptions could affect our ability to reconstruct something, to fill gaps, but also if there might be climate variations that with our current methods we might simply miss. And so there is no second world that really exists, but what we try to do is to essentially substitute the real world by a model world and try to make a little exercise. What you heard throughout this meeting, and I think it comes more and more clear, is that this very big challenge that we as a scientific community have to talk no longer about the global scale picture of climate change, which is really nailed down what is causing the current large scale changes. But what we need to do is to look into more regional domains and actually provide information about future changes at these most relevant spatial scales where decisions have to be made, where both the public, policymakers, and investors would actually see a benefit of this information. And this challenge for us for making predictions into the future is, of course, done with climate models. But how do we test climate models where the underlying data in particular regions might be a few decades, maybe 100 years, but with changing quality? And so what we try to do is to take climate model information, as I said, and try to mimic a real planet so that we can put, compared to this, this figure of spatial variations either in the Northern Hemisphere winter or summer period, what the skill is that we expect that these climate models have to predict in a reasonable sense the really big changes that come along with some of these reductions or increases in precipitation. That's the role of the PR challenge, and you see some of the uncertainties that we try to deal with very specifically in an idealistic way first, and then try to go more and more realistic. From the instrumental record, as I said, it's very short. It has a trend in it, which for calibration is a problem because everything could be dominated by the overall trend, even your interannual scale variations. You have to be careful. There is, of course, in the real world with proxies, the more you are in proximity to anthropogenically perturbed areas, other non-climatic effects that can change your proxies. In the proxy, we heard a lot about sampling, dating issues and how they are affecting your reconstruction, the sensitivity that might change between interannual or maybe longer term time scales, and how the proxy is able to store the climate information and so on. And of course, stationarity in space and time. So what we try to do is to substitute the real world by a climate model, and then go through a suite of tests in some form. We use the the model planet. We test first individual methods. We take samples from this planet and say, given a particular method and taken these samples, how well can you reconstruct the large-scale field? You can then take the same samples but give that to the different methods, something that has not been done, unfortunately, in a systematic fashion. And so we have often a comparison of reconstructions based on one or another method, but there's always apples and oranges. Here we would have, for the first time, really have an apple-to-apple comparison. We can test certain limitations in the instrumental record by imposing some of these uncertainties or removing them and see what the effects are. The same, of course, in the proxy domain, where we can modify the proxies and insert into these samples from the climate model some of our worst fears that are connected with individual proxies and say, if indeed it were so bad, what would be the effect on the large scale? Even when we do it in a multi-proxy way, but what would be the effect in a large-scale reconstruction? And we can go systematically through these different assumptions. What we tried to do is also to steer this community with this towards a more quantitative thinking of what these proxies are, how their processes are driving the variability in the individual records that you're looking at. We need to go to more a quantitative assessment of the different reconstructions. And of course, at the bottom here, so far many things have been done for large scale in terms of temperature because it's a nice smooth field. But we need to really move beyond that, just the temperature. We need to try to see how good are we in assessing what moisture variations look like and then try to interpret these in a more circulation environment, more dynamically. And two ultimate goals, if you want, in the background is to see, is it possible that given that planet and our sampling, that there were climate variations going on that we simply miss? Because we do not have a proxy right in the centers of the action, and we simply missed something that could be of big importance. And the other thing is, by doing and learning how good our reconstructions are, we have been then better targets for past climate variations that we can test climate models if they are capable of reproducing the systematic aspects of what was forced in terms of climate variability in the past. And that's a necessary baseline against which only then you can really make very informed future predictions with these climate models. So very briefly, I really have hardly essentially no time left, this effort is jointly done with NOAA. NOAA is in fact funding our small little effort here that is going on. And we have from the NOAA World Data Center for Paleoclimatology, Dave Anderson sitting over there, wonderful support for the distribution of this data through the data center website. What you see here is our new interface that we put together in nice collaboration with his team that shows you what kind of information you will get. And this is systematic through all of these exercises where we test these individual assumptions. It will always start like this. You see it, you get the data from a world where in the gray shaded area, this is going to be your instrumental record where you have 100 years of high quality crude type uncertainty instrumental data available that comes straight out of the climate model plus the uncertainty that we think we have in observations. The little black triangles that you see, that is an extended record that exists in this here environment that goes for another 50 years into the past to 1850 if you take the comparison with our instrumental real record. And then what you see is the distribution of the individual samples that are taken out of the climate model and are run through a particular process model or a noise model that are supposed to represent how a real-world proxy might represent the climate system. And here we can start off very idealistically and say these are perfect samples like stations. But then we can start to degrade this information and say, what if these were all tree ring samples and we assume the worst fear of tree ring research that a large fraction of low frequency is not well represented or is represented in a different way than the interannual variability, and so on. You can imagine, and we go through various proxies. So you can download information. I'll show you just a few things. What we have, come on. Here you see that actually there's one other step before you download the information. What we try to do here with this website is also to push the community in something that actually should be done, sometimes is done, but not commonly done, is that you actually look at the data. We provide here through this interface the opportunity to directly look at some of these proxy records, because usually from the NOAA website, you downloaded some ASCII file that needed many, many steps before you could actually look at it, because you needed to remove headers. Here you can go straight in, click on the point, get information about this, and have even more opportunity here. You click, and you can get straight an information about what this proxy looks like. We're going to add an additional figure that gives you the overlap with the instrumental record at this location, so that you can essentially look at, is this a temperature record? Could this be a moisture record? Because maybe for your method, you need temperature sensitive locations. Yes, you can go throughout the whole network. And then on this side here, you can download the data, which will open this little window up here. And you see you can download it in two formats. And this is download the data that you see here in the NetCDF example. You get all the information fully referenced in NetCDF spatially and in time for the two instrumental networks, the 100-year plus the 150-year network in one set. And then you get a file with proxy data that is in there that is then given by the individual locations with all of the information through. The names that are in here already, you can go to this website, I'll show you the link in a second. They're going to be standardized, so we have one script that takes the data and works with it. It's always going to be identical. The only thing that changes is the number of proxy records and then the characteristics of the climate representation inside. What we now need to do as a community, and this we shouldn't forget, and I really want to take the time for this one slide before summarizing. And this is, we have usually done reconstructions of very standard modes of variability, of an average, of a very large scale, and so on. You see here some representation of this more standard way of thinking. But as we are going into the future and we try to be really relevant for impacts of climate change, there might be other measures that from the impact side would be really beneficial if we could deliver time series for the past, but also capabilities of saying what drives these changes. One could be the location of a storm track rather than just the strength of an NAO index. Things like this might be really helpful, and we need to work on this through this whole exercise with the climate dynamics community that comes through CLIVAR in our case, and develop maybe also on the product end a little bit into the future and more applied to where the information gets used. And I think then our paleo approach and paleo data has even a bigger impact in use for policy and for climate change information. So this is the general overview how this whole exercise is happening. The first is about the whole collection of the different reconstruction algorithms. Everybody that participates can provide that. We encourage you to provide it, and then we distribute this to everybody so that we can really have an open intercomparison of the different methods with some exercise that you just saw where you will know what the target looks like. You can test how good your algorithm works. Then comes a grand challenge, where this is a double-blind experiment. There is a model simulation where you do not know how this history will look like. It's a realistic planet with realistic forcings, but you do not know the target. You will get samples where a specific group of people have decided which proxy types and what noise models will be used, but they don't know what the climate is that they're sampling from. The blind information is going to get out to the community, and we will see how good we are actually doing in estimating our uncertainties for what planet climates can look like. And finally is this post-challenge assessment, where we use this information to maybe feed back to the climate models about where we have good information and what targets are in terms of response to forcings. So here is the link to the website, the new website up here, where if you click on contact at the moment, you're going to get an opportunity to sign up. This is a little blurry here. You have the opportunity to sign up in a list server where you will get all the information as the individual exercises come available, how you can participate, how you get the data. This is all going to be linked right from this site up here, prchallenge.ucar.edu. And I encourage all of you to sign up and to participate and test your methods. Contribute where you think you have targets, climate variables, climate targets that we should, as a broad community, put into our protocol of things that we can try to deliver back to the decision makers. So thank you for the opportunity here.